Good afternoon, class. So for today, we'll be talking about refraction. So last week we did talk about reflection, um, where light rays travel at a straight line. For today, we'll be talking about refraction. So it's a light ray that will change direction when it moves from one substance into another. Um, you can think of it this way. Say, for example, if you're driving by, let's say, Deerfoot, and it's a straight, 5 kilometer uh, 5 kilometer road before you make a turn or something. And then, like in the middle of that 5 kilometers, a truck spilled, let's say, tons of sand on the road. And then you notice that your dad is trying his best to keep the car straight, like traveling straight. But as you pass by that sandy area, somehow the car uh, changes direction, right? Without your dad doing anything, or steering the wheel or something. So that's so it can be it's very similar to refraction. So how so like you will see here, there are some examples here, like optical illusions, like this person here somehow like appears to be headless, or a head without a body, right? But you will notice, as you look straight here, like on this body of water, somehow light is bent towards your left. You see the image? Light turns towards your left, but obviously, above water, light goes straight forward, right? So when the light hits the water here, it bends towards the left. That's the reason why you see the person you see the person on the left side, um, instead of um, instead of seeing a whole body. Like same is true for this one, right? When light is bent, then the pencil appear to be broken, because this is what happens, right? um, Somehow light changes direction when it travels through a substance with a different density. Okay, so let's say, uh, from light, and then sorry, from air. When light passes through air and then it will pass through water, it changes direction because the density of water is different from air. So however, our eyes assume that light travels in a straight line. So that's where the optical illusion happens. Okay, entrance angle, or angle of incidence. So you have two types, and then angle of refraction. So this is the angle of incidence. So you have a normal line, and then the angle of incidence will be like this one. So same as our reflection concept. Then angle of refraction will be the angle from the normal line, and then this line here, the refracted ray. So angle of incidence is larger than the angle of refraction. Okay. So refraction is due to changes in the speed of light. So in space, like 300,000 kilometers per second, vacuum, no particles to slow light ray, right? But eventually, as it passes through the atmosphere, um, so the Earth's atmosphere will refract it, and that's the reason why, in there are days where, you will listen to you will listen to the forecast, or weather forecast, and then they will tell you sunset will be at 5:30, and then it still is 5:35, but still you can see it's already 5:35, but you can still see the sun, right? It's because when light passes from vacuum to the Earth's atmosphere, it will bend. So instead of it just going straight and not hitting you, now it still hits you, and that somehow extends the sunset. Okay, I hope you can visualize that. So on Earth, particles get in the way, so impossible to go full speed. And when it slows down, somehow it bends. The denser the new medium, the slower the speed, the larger the refraction. So the more it bends, the denser, the higher the density the material is. Okay, so you have this lens, concave lens. So lenses are ways of, you know, lenses are used to bend light in order, let's say, for you to see better, or in order to control the amount of light, or the direction of the light. So concave lens will be thinner at the center. Convex lens will be thicker in the middle. So concave, cave here, that's why it's thinner. Convex, Okay, so you have convex here. So we have thicker in the middle. Okay. So for concave lens, you have this. Okay, rays are refracted away from the center. So you will see here. So there's a light ray here. Okay, so you have a ray box here. So light passes from this point to this point. Somehow, you will see at this point it somehow is it becomes spread out, right? It diverge from the center. So now the angle here is bigger. Okay, it is bent outward somehow. Okay, and they will never meet on the other side of the lens. Okay, so you don't have any focal point for concave lens. Okay, convex lens rays are refracted towards the center. Okay, does this remind you of something? And magnifying glass would be one example, right? When you're trying to burn something, and then you have the focal point here, you will try to concentrate the amount of heat here. Then, uh, then you can start a fire using or doing that, right? So rays cross at a focal point. So again, concave lenses they don't have a focal point. Okay, convex lens they have a focal point. So useful because can act as a light collector, forms a real image. So imagine, so if there's no focal point, there's no real image. Image formed when rays meet at a point. So that's the only time that you can see a real image. Image formation, image formed with a convex lens depends on how far object is from the lens. Okay, so I'm guessing that you were able to use magnifying glass before, right? So in order to focus, you need to move the magnifying glass. So same thing, right? In order, so you need to see that you need to get that focal point in order for you to be able to see the image clearly. If the object is placed placed further than the focal point, the image is upside down. It is a real image, okay? And the closer the object gets to the focal point, the larger the image. So like a magnifying glass. If the object is placed closer to the focal point, the image is upright and bigger. This is what happens when with the magnifying glass. Okay, so we'll not be doing a lab today. I will be showing you more and more examples related to this, and hopefully we can plan. Well, I will be planning a virtual or digital lab with you guys. So enjoy the rest of the day, um, and I'll be uploading some assignments very soon. God bless.